problem. Bless you. We've got Abigail here making some candles. She says her income is modeled by this equation, 3x plus 15, where x is the number of candles she sells. So this is her income is this guy. And she says that her cost, how much it costs her to make the candles, is modeled by this guy. So we want to know how many candles she needs to make in order to break even. What does that mean? Yeah. What that means is that's asking when is her income exactly the same as the cost? Well, I know her income is modeled by this. Income is the y. Same thing with the cost here. So we want to know when the pink y is going to equal this blue y. I have an equation for that y that I can substitute in. I know that my pink y is actually 3x plus 15. And I know that my cost, that blue y, is this minus 2x plus 20. So we really want to know this. When does 3x plus 15 equal negative 2x plus 20? Now we could be able to solve this. The tricky part on this one is this setup here. We want to know when income equals cost, means it's the break-even point. That's my two y's equal to each other, so we substitute in the equations. You don't have to hit this step, but I do recommend it. Otherwise, I'm going to show you the most common mistake I see on this. We wind up with 3 equal signs. I'm telling you, that's the most common mistake I have on this, is that people just put the whole pink equation, including the y equals, next to this guy, including the y equals. No. We only get one equal sign. Don't put those equal y's in there. What should we do here? Add 2x to both sides. Let's get those x's together. I want to add 2x. That's going to give me that 5x plus 15 equals 20. Thank you. What do we do next? We'd subtract 15. I'm right there with you. I want to get those x's by themselves, so it's minus 15 from both sides. So we get 5x equals 5. What does x equal? What do we do? Divide by 5. So what does x equal? 1. So how many candles does she need to sell in order to break even? Just 1. So in this case, we don't have to find both. All we needed to do is figure out the number of candles. How many candles? We figured out x. How many candles does she need to sell? Just 1. That's a good business model then. If you make all your costs back at 1 candle sale, that's a pretty good model. Okay, questions on this one? Okie dokie. So we're going to work with another one of those 3 variable systems from yesterday. These are kind of the trickiest of bits that we have in this chapter, and it's also the last thing in this chapter. So we're on page 19, number 2. We did number 1 yesterday, so we're going to do number 2 today. And then we should have time to work on homework and ask questions and stuff, and I'll also get you guys the chapter review today. I like to name my equations just for kind of ease of use. I tend to call them A, B, and C. It's so that we can talk about them together, and I don't have to say the top one, okay, the one in the middle, or the bottom one. I can say A, and you know right what I'm talking about. I can say B, you know right what I'm talking about. And what we need to do here is we need to pick one variable to eliminate out of all three. We're going to do this in two separate pairs, but I need to eliminate out one variable from all three equations, essentially. So we've got our x plus y plus z is 48, our 4x plus 2y plus z is 64, and our 9x plus 3y plus z equals 48. So, what do we notice? None of them are set up horribly for this. Like, we could go for any variable we want. There's one that looks like the easiest one to me. What do you think? What letter should we go for first? Z. I agree. I think Z would probably be our easiest option. You could absolutely take the X's out, totally valid. I could totally take the Y's out, totally valid. We don't have anything set up perfectly though. I have one Z for all of these, and I really need them to have the same number with opposite signs. So I'm gonna have to multiply something. And I'm gonna multiply A. I'm gonna work with A, and I would really like that to be a negative Z. I want it to be a minus Z, because then I could add it here, or I could add it down here. So I'm gonna take my A times -1. What that'll do is that'll change all the signs to make this my minus x minus y minus z equals minus 48, because it goes to both sides. And then if I bring something like b over, and I don't even have to change anything, 4x plus 2y plus z equals 64. This pair, we can straight up add together. I'm going to zoom it in just because it's really small. And what do we get when we add those two together? What do we get when we add minus x plus 4x? 3x. We get a 3x. What happens when we add minus y plus 2y? 1y. We get a plus 1y. What happens when we add minus z plus z? 0 z's. Kind of the whole point. We did that to get our z's to cancel out. And then our last piece here is our negative 48 plus 64. Also known as 64 minus 48, which is going to give us 16. So our z's canceled out here. That's the whole point. So what we wound up with is our 3x plus 1y equals 16. So we took two equations. We took our A and our B, and we got our z's to eliminate out. That is our step 1 from our instructions from yesterday. So if you think about that list, that was our step 1. Then we would need to do our step 2, which is where I take a different pair and eliminate out that same variable. So we've already used equations A and B. That means I have to use equation C somewhere. So let's use C. That's our 9x plus 3y plus z equals 48. And I can partner that with either A or B. But I already know what a times minus 1 is without having to think it, so I can use it again. That'll give us the pieces we need. Equation C is that 9x plus 3y plus z, that's a z, equals our 48. And if we take equation A times our negative 1 again, we'll have our minus x minus y minus z equals minus 48. So add those together. See what we get when we add those together. I'm just going to zoom it out so you can see what we're talking about here. Really. There we go. When we add our x's together, our 9x plus our minus x, how many x's do we have left? What do we get when we add our x's together? 8. We have 8 x's left. What do we get when we add our y's together? 2 y's. What do we get when we add our z's together? 0. That's the whole point. One of them needs to do that. One of them needs to hit a 0. At least one. And what do we get? That's a z. There we go. And what does it equal? 0. It's allowed to be 0. We can have a 0 here. So again, I had my z's cancel out. That's our whole point. So we get 8x plus 2y equals 0. So that's step 1 and step 2. Questions on those bits? From here, you can either do this as another elimination, where I stack these up and make something cancel out, or you could set this one as a y equals and do a substitution. Totally valid. Once we're kind of in the elimination mindset, we tend to kind of just stick with elimination, so I'm going to go that direction. But if you want to do substitution, it totally works. But what we want to do is I want to get this piece and this piece to eliminate out with each other. So I need them to have at least one term where they have the same number with the opposite signs. So how could I make them have the same number and opposite signs on one of our letters? I'll need to multiply one of them, but by what? -2. If I take this blue one over here, that is not the part I wanted. If I take this blue one over here and multiply it times -2, then I should get my y's to cancel out. So if I multiply this by our -2, I'm going to get -6x minus 2y, and our 16 times 2 gives us a -32. This green one, I'm just going to plug underneath. So we're going to have our 8x plus 2y equals 0. So I multiplied the blue one by -2, and I just brought the green one over. And then we do one more round of adding. When we add these together, what do we get? What is negative 6x plus 8x? Yeah, we're going to get 2x plus, what happens to our y's? Cancel out, we get 0 y's, and that's going to equal negative 32 plus 0 is negative 32. So our y's canceled out like we expected, and then we get our 2x equals negative 32. So how can I figure out what my x is going to be? Divide by 2. Now I take this side and divide by 2, and this side and divide by 2. So what does our x equal? Negative 16. So we know what our x is going to be. X is going to be negative 16. Then we need to figure out what our y is going to be. That'll be the next piece we can. Because I know my x is negative 16. So if we look at our equations that had just two variables, just x and y, or we can use just x and y here, or we can use just x and y here. Any of these pieces that have just two letters, I can use to substitute this in. So I'm going to grab the blue one, this guy over here, where I can take my 3x, but instead of the letter x, I'm going to put in our minus 16 plus y equals 16. I'm taking those two pieces. When I take my 3 times that negative 16, we get negative 48 plus y equals 16. So what's our y going to equal? Where's that one out? What does y equal? Yep, this is a 64 because we would need to add 48 to both sides. And we'll get y equals 64. So sometimes we're going to get obnoxiously big numbers. Sometimes we could wind up with fractions or decimals. And that's the thing that happens. So now I know what my x is and I know what my y is. We just have one letter left we got to figure out. So we're going to grab any of these equations. I could use any of these. I could use the a's that are multiplied by -1. I can use anything we want to. I'm going to go ahead and use a because it has the least amount of stuff in it, and no coefficients means no multiplying, so yay. So I'm going to use equation a from the originals. And that means we're looking at our x plus y plus z equals 48. So I'm just copying it down because it's really far away. But we know our x. Our x is this minus 16 over here. And we also know our y. It's this 64 from right above. So I'm substituting in the pieces we know so that we can find that z. Now what should we do? Got some like terms to combine. What is 16 plus 64? I'm sorry, negative 16 plus 64. 48. So we get 48 plus z equals 48. So what is z going to be? What can I add to 48 and make it be 48? 0. If I subtract 48 from both sides, we're going to wind up with our z equals 0, which is totally a thing that can happen. It's allowed to do that. So that is our third piece of this answer. We need to have all three pieces, and the way we write our answer with a normal size pen is with our x first, negative 16. Then we're going to have our y next, positive 64. And then we have our z, which was 0. And this is our answer. And these are the grossest things I think we do all semester. I think these are the worst thing we do this semester. So if we can do this, we are golden. Okay. So homework 6 has, I want to say 2 of those on it, on the back. Maybe 1. I genuinely don't remember. It's been a minute. Has 2 of them on there. 2 3-variable systems on the back. So give those a shot. We have almost 15 minutes. You guys can work on stuff, ask questions. I'm going to pass back some homework, and I'm going to pass out the chapter review. We have a chapter test coming up on Thursday. Okay? So homework 6 is technically due tomorrow. Honestly, you might have enough time to get it done in class, even if you haven't started it. It's got those systems of inequalities on the front, and it's got the 3-variable systems on the back. You guys can do this. Let me know if you have questions. I am happy to help. Tomorrow, we will have the whole time to work on the chapter review, and then Thursday's the test.